Hi, my name is Nurul Aina with metric number 2211511555. I will share about problem statement. The initial design was impractical to carry around, too big and difficult for other users to utilize effectively. The triangle shape of the new design is an advancement beyond the original, making it less bulky and more portable. By designing this way, we sure that it will be much more convenient for the medical staff to fully utilize it at any time and anywhere. Also, with more compact design, this ECG will needed less space to be placed, as we sure medical staff needed more space to put other equipment and machines as well. Moving on, the ECG monitoring system were originally square and corresponded to figure 1 with an extended processing system in shape at the back. Everyone has since developed a more compact triangle form, nevertheless with a steady bottom surface area and an LCD size at the front. The bottom surface area can accommodate the measurement of the LCD in use. Thank you.
One of the most important aspects of healthcare technology advancement has been development of ECG monitoring system. This is the pre-analysis synopsis of why we do some innovation on our ECG monitoring system. First is apparel technology. We have an innovation about the downsizing. Advancement in recent have been centered on reducing the size and increasing the portability of ECG equipment, resulting in the creation of wearable gadget that people can utilize for ongoing monitoring everywhere. S-Suite elements, friendly interface for user. In order to ensure simplicity of use and result, this is can concrete on development user-friendly of our patient. Thirdly is about remote patient monitoring, integration with the telehealth. With the growing integration of ECG monitoring system in telehealth problem, medical professionals now remotely monitor their patient cardiac health using ECG monitoring system.
For our final mini project, we are required to design an enclosure for an ECG monitoring system, aiming to create a suitable casing that can house all the components of the device. The design must be tailored to fulfill the characteristics of how these components work within the casing. This includes determining the optimal order of components for functionality, establishing the size requirements for the casing, strategically placing the LCD, and incorporating any additional design elements necessary for the system optimal performance. The final analysis of our design led us to choose the first design because it satisfies all the requested characteristics, particularly the clear illustration of components in the circuit. The sizing of the design is comprehensive, making it easy to create, and the dimensions used are in millimeters. Furthermore, this design is inspired by a box shape with a recess as shown in the displayed image on the design side, indicating two holes on the left for the connecting switches. For components outer diameter AC adapter connected to the Arduino board. For the right side is the design space of the AD8232 ECG module component. The entire board is constructed vertically at a 65-degree angle and is supported by a solid triangle attached to the main body. The design features an easily accessible LCD positioned vertically in the front for user convenience. The viewing angle for the cover and LCD is set at 65 degrees angle to provide a unique angle of view. The base is supported by the weight of a triangle shape attached to the component base, serving as a horizontal support at the back. As an additional design consideration, we have to decide to incorporate ventilation holes. This decision arose from the realization that when the components are in operation, heat may be generated. To mitigate the potential heat build-up, we opt opted to include a series of ventilation holes in the design. Initially, the design for the cover featured a flat surface where the LCD was aligned with the cover. However, due to safety consideration, we decided to resist the LCD slightly below the surface. This deviation can be observed in design 3, which differ from the selected design due to safety factor and issues encountered in the ANSYS simulation.
Hi, my name is Aisyah Suraya binti Muhammad Hamdan. My metric number is 221151470. I'm going to present the material that we use for our model. So, do you know what is fiber reinforced plastic, or sometimes we call it as a fiberglass? So, fiberglass is a composite material consisting fiberglass fibers formed by a polymer matrix. A combination of this material produces a material that is strong, lightweight, long-lasting with variety uses. So, the two properties of fiberglass that we've been considered is, the first one, fiberglass is an insulator of electricity in which electric current does not flow freely. This is a protection against a short circuits by creating a barrier between a conductive elements. On the other hand, fiberglass is an incredible flexible material for manufacturing. It is easily shipped. This means that the designers are greatly free to produce a complex and unique shape.
My name is Shifa binti Habibullah and my metric number is 221151578. Today, I will talk about analysis of ANSYS that we got for our design. We put the fixed support at the bottom of our design and the force at the in front of our design. It is because we put the component at in front of our design, such as our LED and Arduino. So, we give our force about 100 Newton. It is because ECG is a fragile device where no accessory extra forces can be added in the first place. So, as we can see, based on our picture from ANSYS that we get, the maximum strain is 41.037 micro and the minimum strain is 4.5597 micro. After that, the maximum stress that we get is 0.71821 and the minimum stress is 0.079801. So, at the bottom and at the back of the model is the most stress. As the strain also, it is same just like stress, where the bottom and the back has the maximum volume same as stress. So, this is show that based on our material that we use is suitable because before this we use polypropylene with the same load, but it can't take it and destroy the shape of our model. So that's all from me. Thank you.